Quantum immortality is a concept that pushes the boundaries of how we understand life, death, and the multiverse. It's rooted in the principles of quantum mechanics, a branch of physics that explores the strange and often counterintuitive behaviors of particles at the smallest scales. To understand quantum immortality, we first need to delve into some fundamental concepts in quantum mechanics. At the core of quantum mechanics is the idea that particles like electrons or photons can exist in multiple states at once, a phenomenon known as superposition. For example, an electron can be in several places at the same time, or a photon can have multiple polarizations simultaneously. This idea is famously illustrated by Schrödinger's cat, a thought experiment where a cat in a box is considered both alive and dead until someone opens the box and observes it. The cat's fate is linked to a quantum event, and until observation collapses the possibilities into a single outcome, both realities exist simultaneously. This leads us to another key concept: wave function collapse. The wave function is a mathematical description of all the possible states a quantum system can be in. When we observe or measure this system, the wave function collapses and the system settles into one of these possible states. In other words, reality as we experience it becomes definite only when we observe it. Now, how does this relate to quantum immortality? The theory takes these quantum principles and applies them to consciousness and the multiverse. According to the many worlds interpretation of quantum mechanics, every time a quantum event with multiple possible outcomes occurs, the universe splits into multiple branches, each representing one of these outcomes. In one branch, you might narrowly avoid a fatal accident, while in another, you might not. Quantum immortality suggests that your consciousness continues in the branch where you survive, no matter how unlikely that survival might be. In essence, you never experience your own death. Instead, at the moment of what would be your death, your consciousness shifts to a parallel universe where you somehow survive. This process could continue indefinitely, with your consciousness hopping from one universe to another, always avoiding death. This raises profound questions about the nature of reality and consciousness. If this theory is true, it would mean that from your perspective, you are effectively immortal. You would continue living in increasingly improbable scenarios where you survive by the narrowest of margins. However, this isn't immortality in the traditional sense. Your body would still age, and you would still experience pain and suffering. The difference is that you would never reach a point where your consciousness ceases to exist. You would continue on, possibly in a state of extreme frailty or suffering, as your survival becomes more and more improbable. One way to think about this is to imagine being in a series of near-death experiences. Each time, there is a universe where you survive. In one universe, you might barely escape a fatal car crash. In another, you might survive a deadly illness. In yet another, you might be on your deathbed, only to somehow recover at the last moment. Quantum immortality suggests that you would always experience the version of reality where you survive, even if that survival becomes increasingly difficult or painful. This theory also touches on the concept of identity. If there are countless versions of you across the multiverse, which one is the real you? Or are you simply one of many, with your consciousness shifting from one version to another based on survival? This blurs the lines between individuality and multiplicity, making us question the very nature of self. Critics of quantum immortality argue that it's highly speculative and lacks empirical evidence. While quantum mechanics is a well-established field of physics, the leap to quantum immortality is a big one. Consciousness itself is not fully understood, and the idea that it could shift between universes is far from proven. Additionally, there's the issue of probability. In quantum mechanics, not all outcomes are equally likely. The theory suggests that you would always experience the most improbable survival outcomes. But as these become increasingly unlikely, the chances of them occurring in any universe become vanishingly small. Another major criticism is the question of evidence. How would we even begin to test a theory like this? Quantum immortality is deeply tied to the subjective experience of consciousness, which makes it inherently difficult to observe or measure scientifically. Without solid evidence, it remains more of a philosophical concept than a scientific theory. Despite these criticisms, quantum immortality has captured the imagination of many, appearing in various works of science fiction and popular culture. It's a concept that challenges our understanding of life, death, and the universe, forcing us to confront the possibility that reality might be far stranger than we can comprehend. In summary, quantum immortality is a mind-bending theory that suggests your consciousness might never experience death. Instead, it would continue in parallel universes where you survive, no matter how unlikely that survival might be. This raises profound questions about the nature of reality, identity, and consciousness, making us reconsider what it means to be alive and whether true death is even possible. Whether you find this theory comforting or terrifying likely depends on your perspective. On one hand, the idea of never truly dying might seem appealing, offering a form of immortality. On the other hand, the prospect of endlessly surviving in increasingly improbable and potentially painful scenarios could be seen as a nightmare, one from which there is no escape. Ultimately, quantum immortality remains a speculative idea at the intersection of quantum mechanics, philosophy, and science fiction. It challenges us to think deeply about the nature of existence and the mysteries of the universe, reminding us that there is still so much we don't know about the world and about ourselves.